So today we're going to look at end behavior of polynomials. Basically what's happening as x goes to infinity or as x goes to negative infinity for polynomials. And basically we can look at two things for polynomials. One, we're going to look at the degree. Okay. So degree is simply the largest exponent. We're going to really classify that two ways. It's either going to be even or it's going to be odd. Okay, so we're going to basically look at, is it even or is it odd? Second thing we're going to look at is our leading coefficient. So on that term with the largest exponent, we're going to look at our leading coefficient. And we're basically going to classify that two ways as well. It's either going to be positive or it's going to be negative. Okay? And so based on these two things, if the degree is even and if the leading coefficient is positive, we're going to get one set of end behavior. If it's even and negative, something different, odd and positive, odd and negative. So really we're going to get kind of four categories of end behavior. Okay? And so we're going to kind of box this off into kind of four different looking pictures. And so if our leading coefficient is even, so let's start even and positive. So if I get an even positive, basically what's going to happen is my graph is going to be pointing up and up. Now, who knows what's going on? I could turn a bunch of times, but in the end, my end behavior is going to be up and up. So the way we'd kind of write this would be as x approaches negative infinity, y approaches positive infinity. So as I go left, I'm going up. Likewise, as I go to the right, as x approaches positive infinity, so as I move right on my graph, my y is going to positive infinity. And the reason for this is if I've got an even degree, something like an x to the fourth, when you put in a positive number for x and take it to the fourth, it's going to be positive. Or if you put a negative number in for x and raise that to the fourth power, it's also going to be positive. So that's why on the end, my graph is going up and up, just like on a parabola. Okay, if a parabola was positive a value, it opened up. Now this could have a bunch of more terms depending on the degree. But that's basically the idea. So that's one case, even positive. Okay, second case would be even and negative. So let's look at kind of case two. What if I have an even, but it's negative? Okay, that even piece is going to have kind of the same idea that both ends are going to do the same thing. Okay, but with an even negative, they're both going to point down. So for an even negative, I'm going to have a graph that looks something like this. Again, I've just got a bunch of different turns. Who knows what's going on, with it. But the end behavior is going to be as x approaches negative infinity. So again, as I go to the left, I'm going down. So y approaches negative infinity. And as I go to the right, as x approaches infinity, y approaches negative infinity as well. So basically for an even degree polynomial, your end behavior is going to do the same thing, both going to infinity or both going to negative infinity. So that's the even. So what's the odd going to look like? Well, if it's odd, again, we got two cases. One, we have odd and positive. So if it's odd and it's positive, my graph's going to start down low. Again, might turn a few times, but it's going to finish pointing high. Okay, so think about linear, positive slope linear. The graph went up and to the right. So my end behavior again as x goes to negative infinity. That means as I move left on the graph, I'm going down. So y goes to negative infinity. And as I go to the right, so as x approaches positive infinity, as I move right on the graph, I'm going up, up, up. So y goes to positive infinity. And so again, odd with a leading coefficient that's positive, it's going to start low and end high. So on the flip side, if it's odd and it's negative, then the graph's going to start high, again turn a couple times or whatever, and then finish low. So as x goes to negative infinity again, as I go to the left, I'm going up. So y approaches infinity. And as x approaches positive infinity, so as I move to the right, I'm going down. So I get y approaches negative infinity. So quick recap, you can think back to linear and quadratic as your basic idea, but if it's odd, the ends are going to do opposites. If it's odd positive, it starts low and ends up high. Odd negative starts high and ends low. If I've got an even positive means they're up and up. Even negative, they point down and down. So even does the same, odd does opposite.